6 pattern, not 5, not 10, 6. In the episode, we'll prove why 6 composable patterns that covers every enterprise use cases that we have encountered so far, and why adding a 7 would be redundant. This 6 pattern maps the 5 orthogonal control flow axes. It's a similar design architecture principles that we follow for messaging architecture or any other distributed light service-oriented architecture or enterprise application integration. In this case, we define them as execution order, concurrency, iteration, delegation, and more of that split into the two for coordinator and the agent as tool, with the control and without a control, and the complexity atomic versus the composite distinction, which is in sync and agent. Adding the 7 pattern would most probably going to duplicate an existing axis, or it might be the composition of 2 parallel that already exist. Now here we're gonna quickly go through a couple of the case studies that we have implemented, and these are the watered down case studies. The actual system is far complex than what we're going to present here, but it will give a fair idea how it looks. The first system that I'm going to show is basically a portfolio manager's assistant agent system, which provides a continuous validation when a portfolio manager is actually handling all the analysis through the deterministic and the non-deterministic approach. It runs many deterministic quantitative agents behind the scenes while LLM is making good choices and the decisions that how to route the decision causes and how to choose the correct risk model. All the risk model, all the design is also verifiable and also reproducible. But however, the LLM adds a very important flavor in it by creating a dynamic decision choices and help a portfolio manager to be part of the human in loop. And this implements all 6 patterns. As you see, here we see all 6 patterns, the market to the trade execution include parallel, sequential, loop and predict, coordinator, agent as tool, and single agent. This is a perfect example among I have that shows that how complex systems can be even designed with these 6 simple implementation architectures. We don't need additional implementation because the composition of either of 1 or 2 or more will eventually generate the design that we are anticipating or expecting. The same be implemented for a purchase department or while the e-commerce, where it can actually help them designing the correct decision based on the market and the favorable conditions when they should go out for purchasing the raw material or the upstream dependencies. The same implementation we did for one of the healthcare industry, and that provides them a very good human in loop decision-based parallel agent that generally make around 70 to 80% autonomous decisions on its own. So bottom line is, in going into each and every case study is itself a 1 or 2 hours of workshop on its own. But however, what we show here is the capability of composing these design patterns. These design patterns shouldn't need to be on their own. They can be composed together to cover any use case or the larger business process that we are anticipating. The agentic AI is always about translating the business process, or what we used to know as BPM, into the agentic AI BPM, and then adding the correct agent and actors as we need. And this 6 agent patterns generally covers all the use cases that we probably would need in enterprise architecture. Whenever someone proposes the 7th pattern, let's apply this test. Does it introduce a new control flow axis? Or does it not covered by any of the existing 6 cover axes that we discussed? Or is it composition of 2 patterns that already exist? Map reduce agent is a parallel plus sequential aggregation. A retry agent is basically loop and critique with a pass-through critique. The hierarchical multi-agent is a coordinator with nested coordinators. A supervisor work pattern is either coordinator or agent as tool depending on the state ownership, whether we want to pass the ownership to specialist agent or we want to keep the ownership to the primary agent. Every proposed cell will most likely gonna collapse into this existing 6 primitives. So let's understand how quickly we can make decisions. If you have new agent architecture problem, start here. It will help in most cases. First question, can a single LLM with tools handle the entire task? If yes, you are done. That's a single agent. Straightforward task, one LLM, registrar tool, model-driven execution, and simplest possible architecture. If one LLM is not enough, ask, do the stack require a guaranteed execution order? If yes, the deterministic pipeline to the shared state. And that's the sequential agent. Does it have an independent subtask? No, then fixed order needed. Can subtasks run independently of each other? Well, the answer is pretty much a parallel agent. Output needs an iterative refinement, not an independent subtask. Does the output need iterative refinement against the quality criteria? Then your choice is pretty straightforward as a loop and critique. Refinement is needed, generate plus evaluator in the bounded correction loop. Do you need a dynamic routing? No refinements? Well, if you need a dynamic routing, then you just choose where the state should reside, whether you want to control the state or you want to pass the conversation flow. And that will make, if you want to own the state, it will come to the coordinator. And coordinator delegates the state to transferring part. Now the specialist take over with the conversation. If you don't need a state to the specialist and you want to keep a state to the primary, agent as told. No other state is needed and agent retain the control. All the specialists can get the result. Keep orchestrating. This 6 pattern and 5 control flow axis. It has infinite compositions. That is the agent architecture toolkit. Start with the decision tree and decompose your workflow, the nested pattern until the architecture matches the problem. Please go through all the 6 patterns in detail where I have made the videos. However, I would just give up one practical advice based on my 1.5 or 2 years experience with Agentic AI, how it is spanning across. Simple is a best, not just better. Agentic AI complexity can actually spiral up very quickly. So decision and standardization is far more important than any polyglot conversations that we had for conventional software engineering processes. Agentic AI amplify the complexity and it can spiral up very quickly, where managing the complexity and managing the existing system become very difficult. It can also lead to surprisingly high level of technical debt. So the best advice as I can give is keep it simple, focus on our finite patterns, master them, make them better observed, make them better designed, make them better decisioned. And that is a key for agentic AI success. As sometimes we call in market conditions, is profit is a byproduct. The real product that you are after is a risk management. And I will really put this statement in same context with agentic AI architecture. Your productivity and the value is your byproduct. It will provide you. The risk management is what you are after. So happy coding, happy agentic AI coding. Make sure you subscribe and like and subscribe to this playlist. I'm probably going to add some more 1 or 2 ad hoc videos based on couple of other edge cases which are still yet to be recorded. And thank you very much. I'll see you in the next video.